Fully stacked, less oops, more ops. Kind of a high-level view of DevOps, and we're going to dig in with the foundations first. We're going to go through sort of an overview of what DevOps is, which is short for development and operations. I'm not sure if everybody knows that. Then we'll dig a little further into the team, the cultural process that actually spawns DevOps, which is actually the key part of DevOps that is at the core. DevOps is a culture first. The technology and processes we use are secondary to that. And then we'll dig into the infrastructure a little bit and talk a little bit more about CICD, although our time is short, so we're just going to keep cruising along. And we'll start with the foundation. So DevOps is a practice of operations and development engineers participating together in the entire life cycle of an application or development, et cetera. It's been around for quite some time, and it's sort of thought of as a new concept, but it goes back quite far, especially when you look at larger companies such as IBM and so on. And basically what it's doing is it's shifting the focus of operations further and further into the development area, because typically there was a gap between development and operations. It's a planned response to things that happen actually while you're developing and deploying. And it's a goal-based process essentially of incremental improvements over time. And it addresses essentially several things. I like to think of it more as problems, although the slide says goals. It's solving things such as maintaining the unique snowflakes that businesses have. There's a low confidence in build and deploy. The failure is actually frustrating and horrible to run into. With DevOps, these things are turned on their head and actually help you. You can fail without fear. And basically, you build your documentation and measurement processes and share those with your developers and create a recurring cycle that will encompass more and more of your processes through automation. So my favorite way of looking at DevOps is with the CAM cycle. This was coined by John Willis back in 2010, sort of in the early days of when DevOps actually became a thing. It was initially coined, the term was coined by Patrick Dubois, and he basically said that there's an increase in feedback loops between business and all parts of the delivery process. And thanks to this feedback loop, we can actually increase the quality and the speed of the flow. So, and then based on that, John Willis came along and came up with the CAMS idea, which is basically culture is your basis. You automate small parts, you build in monitoring, and then you figure out how to share that back to the top. And I actually think that culture is a meta culture. We're really lucky with Magento that we have a very strong meta culture, so your business can actually use the sharing from other businesses to build its DevOps cycle. So we're going to go into each of the letters a little bit here. CAMS is basically starts with culture, people and processes first. The interesting thing about this is people will change, processes will change, but the culture will never change. It will just continue to grow. If you don't have a good culture, all your automation will fail and you won't really be able to build monitoring or figure out how to share this. It's basically impossible to do without culture. And like I said, we have a strong meta culture, so you're in luck. Automation. So automation is the second step. You start to stitch together the automation fabric with very small pieces. Simplicity is the key. You build tools for release management. That's the CICD stuff. Provisioning, which is standing up your environments. Configuration management. Systems integration, monitoring and controlling, and orchestration become the most important pieces that you're actually going to build out. The monitoring and the sharing are actually kind of tacked on top of that. You need to be able to measure to improve, but unless you're actually changing something, there's no reason to measure it, unless you want to get a baseline, which is nice. A successful DevOps implementation will measure everything, your people, your processes, everything. There are ways to actually measure things outside of the normal scope that we deal with. You want to define metrics and standards so that you understand what you're working against or what you're working toward. And definitely want to use tools to visualize the things you run into. Sharing is the last bit in the CAM cycle, and basically you want to create your culture through your sharing. This is something like using Confluence or Basecamp or whatever it is, whatever tool you use to continue to build your knowledge base so that your culture, the new people that come in, can hit the ground running, essentially. And it really simplifies their process of learning how to develop. You can bring in junior developers and they have much less issues actually learning how to work with it. So we're going to move on to team. In my opinion, this is another good way to look at DevOps. Find your different team members, your team groups, and work through them. This chart is an awesome example of how I envision DevOps actually looking. Initially I showed a chart that showed it pushing to the left. DevOps is actually filling the interstitial spaces in the processes. So you have it in all parts of the business, whether from the business owners through the development and the systems engineering, your operations, which is your store, and then the customers on the other end of the store. So you really want the feedback from the customers to be able to percolate all the way through to the left, which is actually hard. Oftentimes operations will be dealing with your customer support and you'll never even see these. These can become part of your culture and actually help you build your knowledge base. So individual roles are another way of looking at it. You want to individualize your roles to the specific people in your company. Every company has unique resources in it. So you have an automation architect, a release manager, a security engineer, etc. And pretty soon I'm going to actually change my name to my title to the last one, which is Disruptive Technology Research Technician. I think it's much better than the one I have now. Because it's actually what I do. Almost every day I'm looking for ways to disrupt our processes and make it easier for people, which is interesting because oftentimes people think of disruption as a bad thing. And with DevOps, we're flipping all these things onto their heads so that they become good things for us and ways to learn. So business and operations is where we see a lot of the support for the customers. This is really not just people, it's also the hardware, anything involved, your hosting company, your tax provider, anybody involved in your operational endpoint is part of the business and operations. You also have your development and engineering people. These are people who write and test code, but it's also the tools you use for development, PHP Storm or Zen Framework or whatever it is, Zen Developers Environment. The methods and practices you use, and also the development of and testing infrastructure. So this is usually mirroring your production environment, but should be thought of more in your development and engineering department. Testing and monitoring, usually this is left up to the developers, but it's best to actually separate it out into a separate group. In many cases where I see DevOps fully engaged, there'll be a department that just deals with testing and monitoring. And it's really important to realize that this isn't just, again, the people, it's the processes you use to get that back into your DevOps cycle. There's a wide variety of technologies out there for this, such as JMeter, Gatling, Selenium. There's functional code testing, regression testing, monitoring such as New Relic, and SNMP, which is an old service, but it works really good for watching your servers. Response to monitoring will oftentimes breach this boundary and create tickets that your developers or other people are working on. So you should find testing and monitoring throughout your entire DevOps lifecycle. If you don't, this is someplace you can easily improve. Customers and end users, these are really the important part of your site. Without customers, you're not going to do anything. And end users are really like the administrators or other people. These also can be thought of as the processes that your end users are using, such as how they work with the admin tool, how do they import products, etc. DevOps works to bring all these separated groups together, acting like a hub to fill the gaps. So it's really about filling interstitial space. So let's go through and talk about the infrastructure. Look at the blocks that we deal with and really what is DevOps. So we're going to stay here for a moment because this is a pretty big chart. This describes, in my opinion, the entire DevOps lifecycle. And you have a variety of environments over here on the left where your infrastructure and for your local environments or your deployed environments exists. And as you can see, this is pretty well covered. In a DevOps cycle, you'll be able to stand up any of these boxes from the same configurations, from the same build tools, et cetera. And then when you're actually deploying, you find that you're going to need build tests, et cetera, built in. And the continuous integration tools and the continuous deployment tools, which Bamboo is one of them, that's the one that we use at RoboFirm. And basically, those are used to build and test your code and deploy it. And so the DevOps lifecycle basically exists to develop, build and test, and then operate. Deploy could actually be put in there, and we'll go a little deeper into, I've got a deeper view into the actual lifecycle. But this is a really nice coverage. And as you can see, basically all of your environments are working to push their information into your monitoring service, which then feeds back into your ticket system. So you can see there's actually a recursive loop here happening. And when you're starting out, the important thing to realize is you cannot automate everything at the same time. You're going to want to start with very simple things. Specifically, your Git workflow is going to be your first thing. But let's talk a little bit more about environments and how those actually spin up first. So continuous integration and continuous deployment, which in my opinion, you can basically tack anything on the end of continuous and it sounds cool. So there is a little bit of ambiguity in these things. The continuous deployment means that you automatically will build and deploy into your production environment. Continuous integration is the rest of it, essentially. So they really are the same term, except for CD is just a little bit deeper. So we started with our development environments. These are by far the easiest parts to automate. Your developers will thank you enormously for this effort. It simplifies the entire process of dealing with bringing on new clients because all of your configurations for Magento will be the same almost across them for your infrastructure, especially for your development boxes. You have a bunch of tools in your dev environment that you use over and over. And so on this slide, we have your local developer who is actually talking to, like, say, a VMware, VirtualBox, maybe a cloud server. It doesn't actually really matter what that developer's environment is. And they're using their continuous integration tool to pull in media and application code from either S3 buckets, because we use Amazon, or Git and Composer. And these move into their environment and essentially are done the same exact way you'll see it in the production. And down below, you see basically how we use the feature branching from Jira to accommodate automating the various parts. So when we actually, when a developer finishes a pull request, this automatically builds a test version of this in the cloud so that our UAT people can come along and actually approve it. And this is an incredible concept because what happens is they'll find a bug and immediately the developer can get back to work and continue that cycle, fix it, pull request, test, fix, pull request, test over and over. And that you're trying to build these small cycles into large recurring cycles. And then when they finally do finish it, we merge it into a release branch and push it out to the live environment the same exact way we push it into the development environments. And this is an example of the testing environment, and as you can see, it's essentially the same thing. The only difference is that we actually have release branches underneath the Nginx, as to allow for different release branches to be tested at the same time. This can also be extrapolated out into separate boxes as well. This slide shows it in a single server. And again, they're both using the same Puppet Master, the same Terraform repository. Terraform basically is infrastructure as code. It's very similar to Vagrant, if you've ever seen Vagrant. And it basically works with Amazon, Google, and DigitalOcean, Docker, et cetera, to work the same way Vagrant did to declare your infrastructure and stand it up. It can all be automated via Bamboo or whatever you use for your CICD. So releases, including master, are kept current via Bamboo. Anytime anybody does anything, if you merge into master, it will automatically deploy into production. This is the same as what they were describing yesterday with the cloud environment. So your infrastructure should be considered code. Your configuration also should be considered code. That's actually one of the core concepts of DevOps. Let's talk a little bit about configuration. So configuration includes not only your OS level configuration, but also the base Magento configuration, because you don't store that in Git, at least you shouldn't be. And the reason why is because it's going to be different in each environment. The configuration management tools that exist will simplify this very quickly for you, and the level of effort to get it off the ground is well worth the reward you get after it's started. And I highly advise investing into one of the configuration management tools that you're comfortable with, that fits well with you. In my opinion, it doesn't matter which one. We use Puppet, we like their support, but honestly, I like all of the others just as much. And so one of the really important things to remember is that you shouldn't be using your configuration management tool to deploy your application. These are separate jobs and they should never be mixed. This is really similar to using shell scripts to do configuration management. You shouldn't do that because there's no way to test this. There's no way to see if what you've done is actually working. This is a good example of what it looks like in AWS. So basically you have EC2 containers. These are your boxes. RDS is your database. Elasticache is your Redis. You have S3 buckets. All of this is stood up via Terraform. It's a single configuration file that's about 100 lines long in almost every one of our clients that's stored in Git. We check it out. It's always the same, except for a few key things like the S3 bucket, et cetera. There's a lot of additional services that are used, such as elastic load balancing and auto scaling. Lambda is used to basically do response-based computing. So for log files and stuff, you'll see Lambda getting used a lot. And then CloudWatch and CloudTrail will deal with your monitoring and log collection and so on. This is a slide by Fabrizio, and from one of his slide decks. The URL's on here. Fabrizio's work on this is groundbreaking. Almost everything I've learned, other than the hard lessons I've gone through myself, has benefited from Fabrizio's work. He has 4 or 5 different presentations you can go through that will really get you off the ground quickly with Amazon. This is from his last one, and basically continuous testing and monitoring requires a lot of thought, and he's gone through a lot of it to help. And they are actually doing immutable deployments on Amazon, which is the next step essentially. And so CICD, we've already talked about this a little bit, but what is it really? So Amazon Code Pipeline, this is a really good example of a CICD tool. Bamboo, Jenkins, Travis, there are many others. And basically all that it's really doing is just going through the process of building, deploying, testing, and releasing. And at each point you can automate, whether it's the release branch, the automated peer review that we talked about with the UAT, or whether you're automating tests or deploying to your release servers. And that would be, the CD side of everything. And basically, Martin Fowler said that continuous integration doesn't get rid of bugs, but it makes them dramatically easier to find. Like, you will still have problems. Your developers will still make mistakes. You might not see it in testing, and then you'll need to fix it quickly. And CICD gives you that ability to do that. Even if you get all the way out to production with a bug, you can easily, quickly develop a fix for it, test it, and deploy it. And that's the key to this, that if you don't have a DevOps cycle, you will run into trouble in one of those steps. Continuous testing. See, it's just like tack anything on continuous. It sounds so cool. Continuous integration tools like Bamboo will provide hooks to allow you to test. With Magento 2, this is a lot more thought out. It's still a little young, but the future looks bright, in my opinion. They've really thought through how we're going to tie our various testing, whether it's front end with Selenium or unit tests, through the Magento testing framework, basically. It's a single endpoint for all of your testing. Whereas with Magento 1, we had some we do have options to do this. We do full testing, but you do have to tack things on. There are libraries out there like ecom-dev's PHP unit tests we use to do unit testing, and Magento does the Selenium testing for us, and we also use JMeter tests that were built upon the Magento performance toolkit that they released to do the performance testing. But there's a lot more work to get that working in Magento 1 than with Magento 2. Continuous monitoring. So we use Nagios, at least that's what most people call it. I believe it's actually called Nachos. The original developers even say this, so it's kind of interesting. So basically it's a simple networking monitoring protocol endpoint, SNMP, if you're more into the acronym side. We use PagerDuty that's tied into it to be able to get alerts and monitoring to whoever's watching it, because we have a follow the sun model, so we don't have to wake our developers up in the middle of the night to test something. We've got people over the world to go in and do the tier 1 support. And basically this ties back to Jira and several other tools we run to automatically create tickets for us. And again, you're looking at small pieces of your business and just trying to automate them. Metrics. Maybe that should have been continuous metrics. Would have sounded cooler. New Relic. You get New Relic with the new cloud service. New Relic is one of my favorite tools I've ever used on the internet. I literally have been told that I'm psychic because of this tool. I find issues with servers before anybody notices them because I'm constantly looking at New Relic, and I've built out some tools to help me find them. You get real-time insight into performance across all your applications and infrastructure. Has a huge API behind it that you can tie into and automate things. And it basically can be configured to collect a lot more information than it has out of the box, even about deep into your application or ERP integrations or wherever you need. All of these can be pushed into New Relic to aggregate them. And then we have logs. Logs are a constant struggle with infrastructure. As our infrastructure is fragmented and grown, logs have become more and more difficult to collect and use as a tool. So data sources of interest, you have your normal infrastructure metrics. These are things like CPU, network, I/O, other things of that nature. Your business metrics, signups, conversion rates, logins, orders, etc. Events, these are things like deployments, auto-scaling moments. There's a lot of different events that can happen throughout the business cycle, and you really want to be able to aggregate those back to your log files so you can see what went right, what went wrong, etc. And then, of course, your testing metrics. You want to tie your tests that you do for your unit testing or whatever back to the releases that you're on and so on. We use ELK, that's Elasticsearch, Logstash, and Kibana, and we use a software as a service provider called Logs.io to deal with a lot of that. Although you can easily set this up in your testing environments fairly quickly and get it off the ground, but if you're going to push it out into production, there's some scaling issues that you'll need to accomplish. That's why we use the software as a service. There is actually quite a bit of more information on logs, especially the ELK stack. I have a presentation. If you look up on SlideShare, you'll find it. And I actually really love ELK stack. I could talk about that for hours. So let's move on. Creating a DevOps blueprint. So how do you actually set up DevOps? The DevOps plan. So basically you want to define, document, and empower your DevOps culture. What this actually means is that you're going to identify and document your processes. You're going to find people that are in those roles, and then you're going to focus on building the foundation for those feedback loops. At this point, you've not automated anything, but you have empowered your culture. And that's the baseline for your DevOps. At that point, you start to automate. Typically, you'll see the application build process be the first thing you automate. Secondarily, you'll see your development environment builds, and then you'll build your testing, and then finally be able to do this at production. It's very nice that we have this in the cloud as a service with the PaaS thing, because this is already all done for you. At the end, you need to think about building monitoring metrics in everywhere. You could probably insert that in any one of those bullet points. You're going to want to start building monitoring and metrics in very early in your process. It is the point where everything loops back. And yeah, let's talk a little bit about the building blocks. So you start with your Git workflow. Rock solid Magento development by Fabrizio. This is where I learned how to do this, and we literally built our process around that presentation. And after you're done with your Git workflow, and that's to be able to do feature branches and release branches, et cetera, and really nail that first. And then work on the application build process. So how are you going to actually build your application? What this means is that there's artifacts in the build process. If you're using Composer, this is your vendor directory, for instance. But there's a lot of them, actually. And these need to be actually thought through on how you're going to actually build them and deploy them. This means that you really want to start with just the build process and get that down before you actually figure out how to deploy that, and be able to repeat it over and over and over on a local box. Testing and peer review. Release build process is basically the next point. So that's where you actually get the CD, get it into production, allowing you to automate your production deployments. What I meant by that, essentially, is that you can actually do builds non-automated. I suggest actually getting your build process for production working perfectly. Once you have it working, then build the automation on top of that. Lastly, you'll probably see operation monitoring to plan the next release, essentially iterating, repeating over and over. You want to keep everything simple. You really want to make sure that every piece that you do is as nuclear as possible, like not able to break it up. The biggest downside of DevOps is that it's a Pandora's box. Once you've opened it, you have a lot of tools in your toolbox there. You don't really know where to start, where to go with it, etc. So when you start small, it's much easier. You just take one piece at a time, building each and weaving them into a process that you call your DevOps fabric. So yes, keep it very simple and build very small.